Welcome back to Coding Shorts. My name is Sean Wildermuth. With .NET 9 looming this fall, I thought I'd cover some new things in ASP.NET Core that are coming with .NET 9. The .NET 9 is not a long-term supported version, but you're going to be able to use these new features going forward with .NET 9, 10, and etc. So whether you want to jump on the .NET 9 bandwagon early and know you're going to upgrade to 10, or wait until 10, you'll still be able to use these same features. Before we get started, I just want to make a quick plug for my upcoming workshop, Pragmatic Architecture for ASP.NET. You've missed the early bird pricing, but you can still get $50 off the price of $349 down to $299. Again, the course is on August 26th, and I hope I'll see you there. Today we're going to be talking about caching, and it's interesting because we really have two implementations of caching right now. In-memory caching, that's going to happen just on a machine, and of course that cache will be lost if that machine needs a reboot, or of course with timeouts. We have a distributed cache that allows us to have a cache somewhere outside of our process. So this is often things like a Redis cache or a SQL Server cache. Introduced in .NET 9 for ASP.NET Core is going to be something called the HybridCache. That's what I'm going to show you how to use. Let's get started. So I'm in Visual Studio, of course, using a really simple project I have that just has a view app that can show an address book, and then we're going to focus on using the API, which is using ASP.NET Core. And if we run this, just so you can see what's happening, you can see we get this list of different users because that's used so often. And as we switch these, they're actually going to the server and pulling down all this information. But more importantly for me is that this list might need to be gotten quite a bit. So I want to be able to cache this. And in fact, our code is caching it. Come here to my API for entries. Let's go ahead and look at getLookup. What getLookup does is it has a memory cache that's being passed in. And this is registered by just adding a memory cache here. So that means we can go ahead and put things in the cache by injecting the memory cache interface. And I'm going to first say, can I get it? And this is going to get whatever data I'm trying to store in there, in this case, the entire list. And then I'm using some sort of string key to look it up, though strings don't have to be the way you look it up, but it's a common way. And if it doesn't find it, it goes ahead and reads the database and then caches the whole list so that the second time in, it should be a lot faster. Super simple, probably seen this 100 times. And the problem here is this cache is only in memory. And a lot of times for high volume sites, memory is going to be the fastest way to get this. But if you're running a number of web servers, you might not want to cache it on every machine. There might be overhead for memory, or you may just want to have the fastest version of that. What we'd normally do is come in here and replace our add memory cache with add distributed memory cache. This basically needs a backing data store, something like Redis. This would create the same sort of cache, but we actually have to use it differently here by saying distributed cache. I'm not going to actually implement this quite yet, but I could say I distributed cache, and I'll probably need another namespace. And this cache is a little different in the way it actually gets and sets. So you might assume that iMemory cache and iDistributed cache come from the same basic interface, and they don't. They act in different ways. The biggest difference between iMemory cache and iDistributed cache is there's no synchronous getting of this cache. You have to do it asynchronously for obvious reasons. It's going over a network or going over at least on machine to some sort of cache. They don't want that to ever be synchronous for obvious reasons. It could be too long and locking up a thread and all of that. So what has happened instead is that when we move to .NET 9, so we open up and just change this to 9. Isn't that interesting, but go ahead and rebuild this and it should run the same. Might need some updated versions of some of the libraries, but I'm not going to do any of that. Now that I have 9, I want to go ahead and add a new package. And the package is Microsoft Extensions Caching Hybrid. And notice the preview 6 of .NET 9. So obviously this doesn't work with .NET 8 yet. We'll go ahead and close that. We can now change this to add hybrid cache. So what's happening with HybridCache? Let's go over and re-implement that API caching using the HybridCache. In this case, there isn't an interface. It's actually just HybridCache, which we'll need to bring in the HybridCache namespace. It's going to complain just like it did before about get. But in HybridCache, they've done something interesting. They've tried to make this into a one call, because you can see a lot of this that's happening, that what often will happen is we need to repeat this code over and over again. We're going to leave our book entry there there, but instead of calling get, we're actually going to be calling get or create async. Now this is still going to store the same data in it. So it's going to take that lookup key, but the other piece it needs here is actually a factory that returns the data that you want to cache. And all that will be is this. And the second parameter here is going to be a lambda for us to return that same data. We're going to use this repository just to go get that. And this is expecting a cancellation token. I'll just say token there. Let's make it async, because this operation is async. And now we're getting the error because, of course, this needs to also be awaited. We can get rid of all that code because when we come in here, we're going to go ahead and get our lookup from the cache. And if it's not in the cache to return, what we're actually going to do is create this, cache it, and then return it to this lookup. Hopefully, the idea at least is to more easily get and handle the creation of these caches. And so we run this again. We're getting it and it's being cached because none of this really broke it. But looking up these entries to make sure they're cached is a little funny because this lambda is only going to be called if the cache didn't find our lookup key. That's the only reason it would ever get called. And so we're calling this a hybrid cache, right? That means it should be able to handle both methods. And what a hybrid cache really is a memory cache with an optional second store for a distributed cache. So it'll always cache in memory, but if the cache is invalid in the local, it will go look at the secondary source, which will be an external or a distributed cache. How do we make this actually use the distributed cache though, right? Let's come back here, and I'm just going to use a Redis cache. And there's actually a library out there from Stack Exchange that makes this pretty easy. So let's manage those Nuget packages again. And this time we're looking for Microsoft Extension Caching Stack Exchange Redis. This is the data access library. This isn't the server. Go ahead and install that real quick. And then all we need to do here is add the Stack Exchange Redis cache. And this will take a Lambda to configure it. And the only configuration it needs is configuration, which is essentially a connection string. Now I could put this in configuration if I want, but I'm just going to go ahead and say just localhost, because again, I'm running a container. And I don't want to get into how to run containers and all that. I might be covering that a little later for containers that you want to use during development or testing, but I'm not quite there yet. And the standard port is 6379. Now what this little library does, there's one for SQL Server as well, is adding a dependency of distributed cache. So let's come down here for a minute, and just to prove to you, if we run Redis Commander, which is just a local web server to attach to our Redis so we can see it, and here we can see Redis, but it doesn't have any data in it. We would normally be able to see the data over here if there was data, but it isn't, but it is connecting to our version of Redis, and that's great. How do we take this distributed cache and tell HybridCache about it? Well, in fact, we don't have to. The reason is pretty simple. The hybrid cache will look for a dependency for distributed cache, and if one exists, it will use it as that secondary cache. But you now can see our lookups are in Redis cache, and there's all the data we stored. Make sense? And just to complete the whole end run is we also have methods down here for post, put, and delete. And in these cases, I want to be able to remove the entries. Now, currently we still have that iMemory cache, but that's actually what we want, right? We want to say hybrid cache and remove async. Simple enough change from what we've done before. And this was just done, so we're invalidating the cache. We're not reloading it, we're just invalidating it. Make sense? So if we had added or edited an object, it would be cached next time we requested that list. All this code would be available. You'll see a link down in the show notes to get it. But let's go ahead and wrap up. We're at .NET 9 now, which means we're at ASP.NET Core 9 as well. And so the number of new features that are coming into ASP.NET that aren't related to Blazor are pretty small. In this video and the next video, I'll talk about two little ones that can impact you a little bit, but they're not going to be earth-shattering. They're not going to change everything you're doing, and I think that's a good idea. It feels like we're getting to a maturation point with ASP.NET Core that we can start to have a lot of things built on top of it instead of worrying about reinventing it all at once. Again, I'll put a quick plug in here before I ask you to like and subscribe for my August 26th virtual workshop on Pragmatic Architecture in ASP.NET Core. Don't forget to use the coupon to get $50 off the course. For Coding Shorts, this is Sean Wildmuth. I'll see you next time.